Okay, in this video we're going to talk about perfect squares and square roots. And the first thing that we have on our first page here is the perfect squares. So we're going to fill out this chart right here to show you how to model a perfect square, and so you can get a better idea on what a perfect square is. Okay, so go ahead and get ready. Here we go. The first thing we're going to model is 1 times 1. And 1 times 1 in the exponent form would be 1 to the second power. Now if it would have been 1 times 1 times 1, that would be 1 to the third power, and then 1 times 1 times 1 times 1 would be 1 to the fourth power, and so on. Okay, so the little bitty number, the exponent, tells you how many times you're going to multiply that big number, the base number, by. Okay, so a couple of vocabulary words. The big number, that's called the base, and the little bitty number, that's your exponent. Okay, that little bitty number is your exponent, the big number is the base. Now to model this is just a square that has 1 by 1, so it would just give me one little bitty square, because this is worth 1 and that's worth 1. 1 times 1 is 1, so my answer is just 1. Okay, actually we don't even need to write that answer right there. Now the standard form. The standard form is the value of 1 times 1. What's the value of 1 times 1? 1. We're done. Okay, so now let's look at the 2 times 2. 2 times 2 means 2 to the second power. And again, if it would have been 2 times 2 times 2, that would have been 2 to the third power. And if you do 2 times 2 times 2 times 2, then that would be 2 to the fourth power, because there is 4 2's multiplied together. Okay, but we're not looking at these over here. Let me put a line through those. Let me change this color. Okay, so we're not looking at this one and we're not looking at that one either. Okay, but we are going to be looking at another one. So let me change this one color to darker blue. Okay, so we're not looking at that one either or that one. Now the model. Since we're not looking at these, that was just extra information. Don't cross them out like I did on my paper. Just go ahead and leave them out for yours, for your example. But 2 to the second power, that means a square that's made up of 2 squares on either side. So this is now 2 squares and this is now 2 squares. But does this look like a square? Nope. But if I fill it in, now it's a square. So 2 times 2 equals 4, right? So my standard form would be 4. So if you're noticing what we're doing here, the number that we're squaring, that base number, that's the length of the side. And then the standard form, that's how many squares we have total. Here we only have 1 square, so it's just 1. Here we have 4 squares, so my answer is 4. But the number that was being squared was the 2. So we're just looking at the side. How many squares are on one side? Okay. Let's do 3. 3 times 3 would be 3 squared. And that means that you would have to have 1, 2, 3 square on one side and 1, 2, 3 square on the other side, because we're trying to make a perfect square. Now this doesn't look like a perfect square, so I'm going to have to fill in the rest of the squares, and that looks better. So now we know that there's 3 on the top and there's 3 on the side, and there's a total of 9 squares. So 3 squared is the same thing as 3 times 3, and 3 times 3 is 9. Or we have 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. That's why 9 is the standard form. Okay, so I'm going to go ahead and let you figure out the rest of them, the 4s and the 5s. Now go ahead and go down here to, or turn the page to the next page, and it says, which perfect square is being modeled? Write the exponent, and standard form. Okay, so if we go back and look at the exponent form, the exponent form is the one that has the exponent on it. This is the exponent form. And the standard form is how many squares total we have. Okay, so let's go back and look at that. So we have 1, 2, 3, 4, 5, 6, 7 squares up here. And we have 1, 2, 3, 4, 5, 6, 7 squares on the side. So that means 7 times 7 would be my problem that I would be working here, and 7 times 7 is the same thing as 7 squared, which equals to 49 total squares. If you count them all, you get 49 squares. Okay, on this one you have 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So I'll let you figure out what goes in this spot right here. Okay, remember, exponent form and standard form. Okay, now let's talk about find the square of each number. So in this case, it's just to find the square of a number, multiply the number by itself. So this is basically what we're used to seeing already. So 12 to the second power means 12 times 12, which equals 144. And you can work it out if you need to. You'll see you'll get 144. Okay, now on this one, 17 squared, if you don't know that one by memory, you're going to have to work that out. But go ahead and write down 17 times 17 and then work it out. Work it over here on the side, 17 times 17, and whatever you get, make sure you put right there in your answer, okay? Alright, then the last question for perfect square says, which model represents 4 squared? Well, remember, 4 squared means that the 4 is the number that you're multiplying by itself. That means 4 times 4. So the model should have 4 along the top and 4 along the side. And you should have all of this completed to look like a big square. Now I know this is not a pretty form, but I don't need to make it a pretty form because the answer is right here. 1, 2, 3, 4, 1, 2, 3, 4. So it gives me 4 times 4, which is 16. Okay, so the question just asks which model represents 4 squared. The answer would be C. If you look at the next page, now we're talking about the opposite, square root. Okay, square root is the factor that is multiplied by itself to form a perfect square. And we use this sign right here called the radical sign. Okay, this radical sign is very important that you know how to draw it correctly. It's kind of like a division symbol, but it's kind of slanted a little bit. And it's got this little tail or a little foot right here. Okay, and that's called the radical sign or the square root symbol. And we use it to indicate the square root of a number. For example, okay, so the radical form is square root of 1. Well, square root of 1 is modeled this way. It's just 1 square. So if we want to find the square root of 1, we're looking for how long is the side of that square. And since we only have 1 square on this side and 1 square on this side, then the solution is just 1. Okay, so now we're going backwards. Now we're not looking for how many total squares we have. We're looking at how many squares we have on one side only. Let's look at the next one. 4, square root of 4. I'm going to draw a square with 4 squares inside of it. Now I have 1, 2 squares on the top. So these 2 squares and then these 2 squares, that tells me that 2 times 2 equals 4. So the square root of 4 is 2. Okay, and then the square root of 9 would be the same thing. You have a square with 9 squares inside of it, and that means that you have 3 on the top and 3 on the side. So that's 3 and 3. 3 times 3 equals 9. So the square root of 9 is 3. It's kind of working backwards, just looking at what number inside the radical that we have in there, what numbers times itself will give us that number. And in this case, is 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So I'll go ahead and let you fill out the rest of it. That's 16 and 25. And on the next side is which square root is being modeled. Well, we're looking at this one right here, right? So we're looking at the square root, not the perfect square. Be careful with that, because a lot of people get that mixed up. So if we're looking for the square root, we're just looking for the side or the top of the square. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 there. And 1, 2, 3, 4, 5, 6, 7, 8. And there's 8 right here. That tells us we have a square. And the 8 times 8 would be 64, but that would be the perfect square. We don't want that. We just want the square root, because that's what the problem says right here. Which square root is being modeled? And in this case, the square root of 64 is being modeled, which equals to 8. And finally, here we go. We have to find the square root of a number. Find what factor multiplies by itself to equals the perfect square. So in this case, we have the square root of 81. So the square root of 81 is simple to find, because I think you already know that one by heart. But what I want you to do right now at this moment, I want you to go ahead and write down 1 squared equals 1 times 1, which equals 1. and then make you a list. 2 squared means 2 times 2, which equals 4. 3 squared equals 3 times 3, which equals 9. And 4 squared equals 4 times 4, which equals 16. 5 squared equals 5 times 5, which equals 25. 6 squared equals 6 times 6, which equals 36. 7 squared is 7 times 7, which equals 49. 8 squared equals 8 times 8, which equals 64. 9 squared equals 9 times 9, which equals 81. And 10 squared equals 10 times 10, which equals 100. And you might find it beneficial to keep going, maybe 11 times 11, 12 times 12, 13, 14, 15, and have those already written down for whenever you come into class. Okay, because if you have all of this written down by the time you come into class, then the worksheets that I'm going to give you in class are going to be a piece of cake to you. So go ahead and write those down. And I'm not going to give you these. I'm going to actually make you multiply them out so you can see what they are. Okay. So now that I have this list right here, if I'm looking for the square root of 81, now all I have to do is to see where 81 is. Oh, there's 81. So the square root of 81 is 9, because 9 times 9 is 81. So once you have the list, it's really easy. All you have to do is look at it and find the correct one. Okay, if I'm looking for the square root of 121, well, the biggest one that I have here is 100. So that means it's going to be one of these over here, and you have to figure out which one it is. Okay, now let's go to the next problem. And this one says the model below represents the square root of 36 equals 6. Which arrangement can be used to represent the square root of 225? So the model they give you represents this information right here, 36, square root of 36 equals 6. Because you have 6 on the top down here, and you have 6 on the side right here. So that's 6 and 6. So that should be a total of 36 inside here. So if they want to know this, what model would represent the square root of 225, well, we have to have 225 in the middle somewhere, and we don't want to know how long that's going to be, and we want to know how long that's going to be, the sides. So we're going to have 2 rows of 15 squares? Probably not, because we know that this number and this number have to be the same. So by just looking at that information, the 2 and the 15 cannot be right. 2 and 25 cannot be right. The only answer is 15 times 15 or 25 times 25. So if you multiply 15 times 15, do you get 225? Or if you multiply 25 times 25, will that give you 225? Whichever one gives you the answer, that's going to be your answer, C or D. Okay? So make sure you know how to do that. And finish these notes. I'll see you in class tomorrow. Thank you for watching.